So here's a couple of general comments about the test. Okay, number one, show your work. If you have unsupported answers, don't expect to get hardly anything for it. Not a personal accusation, but how do I know you just didn't cheat and just see it on somebody else's piece of paper? Show me what you did. How did you get to that point? Okay, I am literally grading every test through a magnifying glass like this, looking for every detail. There's not one thing you could slip past me like that, right? If there was a minus sign missing there, and then all of a sudden you recovered there, I'm going to notice it. I mean, that's just the way it goes, because that's a level of math that in Algebra 2, in the end, they just didn't care. Okay, can you pass your SOL at the end of the year? But believe me, every little detail counts, so show it. And don't do things that weren't asked for. It just convinces me that you either can't read or don't read or cannot understand what is basically simple English paragraph saying do this, do this, do this. Just do the things you're asked for. If you have that in your mind and end up doing things that aren't asked for, in my mind, you really didn't understand the directions. So you just start throwing everything at the wall and hoping you get credit for something in there. And if that's not what's going on, you can inform me then why did you do things that really weren't part of it? So answer the questions that are asked. Right? The first one was put it in standard form. Right? That was the only thing you had to do. And we learned two different ways to do it. Okay? What we did not do was just put it in the calculator, find a max or a min. It was never part of what we did. Okay? If you want to know how you're supposed to do something, do it like we did. Okay, don't come up with other ways of doing it. I don't want that to be the only way you know how to find a vertex of a parabola. Right? You're supposed to know how to do this stuff. Remember, if you complete the square, which I believe just about 0 people did in both classes, right? You would have factored out the 2 or the negative 2, and then you would have added a 9, which is actually a negative 18, and then you would have added 18 to balance it out. And that gives you negative 2 times x plus 3 squared plus 5. If you did the h equals negative b over 2a, I mean, you're still going to have to get negative 3 as the h and plug it back into the equation and get 5 for the k, and then plug those back into this, right? So there's the negative 3, there's the 5, and where do you get the a from if you do it that way? It's the same one as the standard form is right there. Okay, second one, you were given a vertex and a point and said, write the standard form of the quadratic. So again, the standard form looks like this, a times x minus h squared plus k. We have to fill in for the h and the k and the a. But the h and the k are given. So that part is the easy part, right? Don't expect a lot of credit for just plugging in a 6 and a 2. Then you got to figure out the a. And how do we do that? Yeah, the point represents a value of x and y that go together, right? This is a point on the graph. So if you plug in for x, the negative 4, and for f of x, or y, the negative 1, and solve, then negative 4 minus 6 is negative 10, squared is 100. Okay, now, at this point, there's a couple mistakes, and these are just basic algebra mistakes that we shouldn't be making. 100a plus 2 is not 102a. You cannot add those terms, right? They're not like terms. One's got an a in it, one doesn't. Okay, there was a few of doing that. And then there was a few that actually subtracted 2 to the other side and got the negative 3 equals 100 times a. And then for their a, they had 100 over negative 3. Right? When you solve for a here, you divide by 100. That's negative 3 over 100, not the flip of it. That's pretty basic algebra, right? Okay, the next one said, here's a polynomial, 3. Well, in the problem it was there. Reduced to a quadratic by dividing out the zeros. Okay, what kind of dividing would we most likely do? Synthetic division, but there were some that did long division. That's fine. It doesn't matter. But if you do long division, what would have been the factor that you divided by? X plus a half and x minus 1 if you did the long division. If you did synthetic division, which really is what we expect, then right? You write down the coefficients. I should point with this so you can see. Write down the coefficients of the polynomial, and then it's the zero itself, -1/2, that goes in the bracket. I don't think we made many mistakes with that. And then you go through the synthetic division. -1/2 times -2 is +1. Add it up, you get 14, and so on down the line, right? We got a remainder of 0, which we should have because we were told it's a 0, right? And then we do the 1. Remember, you do the 1 on this row of numbers. You don't go back up to here and do it with a 1 in the bracket, because what you will do is you will, for the second time, reduce it from a 4th degree to a 3rd degree, but you won't get it to a quadratic, right? This, dividing out the -1/2 brought you to a cubic, and then dividing out the 1 takes you to a quadratic, and then you put the x's back in. Here's your quadratic, -2x squared plus 12x minus 6. Right, but don't keep going back up to here. Okay, the next one was list the possible rational zeros of that polynomial. Okay, well, how do we find the possible rational zeros? That would be the factors of 32 divided by the factors of 2. Okay, now that's not the end of it, right? First, you write down the factors of 32, and because 1 times 32 is 32, and so is -1 times -32, you always put plus or minus, right? So it's plus or minus 1, 2, 4, 8, 16, and 32. Those are the factors of 32. And then in the denominator, the factors of 2 become plus or minus 1, plus or minus 2. Okay, now you got to take all the combinations of what's in the numerator and denominator. This is not the final answer. Right? The final answer is once you've gone through and said 1/1, 2/1, 4/1, 8/1, and all the way to the end. That would have given you everything from 1 to 32. Then you go 1/2, that's a half, that's new, right? But all the rest of them are repeats. 2/2 is 1, already in the list. 4/2 is 2, already in the list. 8/2 is 4, 16/2 is 8, and 32/2 is 16. Already in the list. So that was your list of possible rational zeros. Okay, and it didn't say now start dividing by that, right? That was it. Just make the list. Done. Number 5. Five was write a polynomial if you know 2 of the zeros. Actually, it says find a quadratic, which is a polynomial, if you know it has zeros of 1 minus the square root of 5 and 1 plus the square root of 5. How do you turn zeros into factors? Right? You write x minus the 0, right? The factor is x minus whatever the 0 is. That way, if I plug in 1 minus the square root of 5 for x, then 1 minus the square root of 5 minus 1 minus the square root of 5 is 0. That's why this is the factor. Okay, now from there, you really should take a step and distribute that minus. Okay, most of you don't do that, but because of the nature of the problem, you still, if you just wrote down these numbers and then write down these numbers here and here, you could end up with the right thing. But you really should distribute. And then multiply. Right, multiply for this term, x times x, right, x times x, put it there. -1 times -1 goes there, right. For the most part, people filled this up okay. A lot of you got the first 2 terms, which means you had all of this correct right here, but then you missed the constant term. And you did things like the square root of 5 times the square root of 5, you said it was 25, right? It's 5. It could be the square root of 25, but that's 5. So it should have just been the -5 here. The positive times negative made a negative, and the square root of 5 times square root of 5 is 5. And then combine the 1 minus 5 to get -4. Okay, the next one was a purely just multiply. And what do you notice about those 2 factors that you're multiplying? They are conjugates. They're conjugates of each other, which means really you could FOIL the whole thing, or you could just go the first and the last, because the middle terms, the O and the I, will cancel each other out if you do everything else correctly. Remember, conjugates just differ by the sign in between the two terms. So that's a minus, that's a plus. So the negative 6 times negative 6 should have been the 36. The square root of 5 times square root of 5 is going to get you 5. Okay? And the negative I times I is negative I squared. So that's still a major mistake that we make, is making the I squared and then dealing with the I squared. Right? What does I squared equal? Negative 1. So really, it turns that whole last term into a plus 5. So it should have been 41. And there was a fair amount of 31s because you didn't take into account that minus 1. And definitely should not have been any I's in the answer because they should have all canceled. Okay, the next one was a simplify, right? Simplify this quotient of imaginary numbers so that it's in standard form. So the number one thing is you gotta multiply by the conjugate of the denominator, right? So because as we saw up here, when you multiply conjugates, you eliminate the i's. That's what we're trying to do. So we need the conjugate of the denominator to eliminate the I in the denominator. We expect there's going to be an I in the numerator. That would be the standard form for a complex number. So you do the 1 plus 2i over 1 plus 2i, and there you go. It should have been, there's a lot of mistakes on here. What do you get when you multiply negative 2i times positive 2i? That's negative 4i squared, which is plus 4. There was a lot of having 2 there. So you ended up with a 3 in the denominator, which was not right. And again, you know, what's the one term that was going to give us trouble? It would be that last one. The negative 7i times positive 2i should have been negative 14i squared, which is plus 14. Okay. Number 8. Number 8, the directions on number 8. Where are they? Find all the zeros. It was even underlined. The all was underlined. How many zeros do you have to find since it's x to the 4th? 4, right? You had to find all 4. What most did, it looked like, was probably look in the calculator. You saw the negative 5 and the 5, and then you just stopped. So you didn't make any attempt to get the last 2. So it should have. Now you could have done this, right? If you factored this as a difference of squares, right? 625 is 25 squared. That would make this x squared minus 25, x squared plus 25, right? The x squared minus 25 gives you your x plus 5, x minus 5. That would have given you the zeros that you saw in the calculator, negative 5 and 5. And then you could have set that equal to 0 and solve, plus or minus 5i. Or you could have done synthetic division, right, on that and reduced it to, eventually you would have got to that anyways. I think some did that. Okay, number 9. Find a polynomial with integer coefficients if you know it has zeros of 0 and 1 minus 7i. There was a few that looked at that and then said that the zeros were 0, 1, and negative 7i. But that's not what it says, right? It says 1 minus 7i. That's one complex number, one imaginary number right there. So you can't create something out of thin air. It's not a 0 and a 1. It's just 0 and 1 minus 7i. Okay, well, which 0 do we have to add to that list? So 1 plus 7i. So it should have looked like this, right? If these are my zeros, then I turn them into factors by putting an x minus in front. And there's a lot of, like, you're still not doing that part correct. You make one of them x minus and the other x plus. It's not that. Remember, the thing that changes in the conjugate here, that's inside the parentheses. That's a minus, that's a plus. But what's in front of that is always x minus, always. Right? Again, this is one that you really should have distributed the minus, and then if you wanted to use this 3 by 3 grid, you know, you'd be in good shape. If you didn't distribute the minus, it still worked out just because of the nature of the problem. So then you just had to multiply everything correctly. Again, more people than you would have thought, when they multiplied 7 times 7, got 14. Okay? Which we shouldn't be making that mistake. If you know you're that weak in your math, you should do it in the calculator. Right? So it should have ended up being that last term, a 7i times a negative 7i was positive 49. And that combines with the 1 to give you a 50 at the end. And then, don't forget, you had the 0 of 0, which meant you had a factor of x. And so you had to multiply that by x. And so that was the final answer. Okay. The next one was find the maximum. No, let's be clear about this. The next one says, right, the profit P in hundreds of dollars that a company makes depends on the amount X in hundreds of dollars that the company spends on advertising, right? And there's the equation. So this is profit P as a function of X advertising dollars. So what expenditure for advertising results in the maximum profit? What are you being asked for? The X, which is going to be the H in this problem, because since this is a parabola that opens down, that the maximum is the vertex, right? But you're not being asked for the maximum profit. There's nothing in here that says, and what is the maximum profit? It just says, what should we spend on advertising to get the maximum profit? And so you should have done the negative b over 2a. And if you did the negative b over 2a, that's the b, that's the a. Even though it's written reverse, right, it's still, the a is the coefficient of the x squared term, not the 230 just because it happens to be written first. Right, so make sure there should have been negative 20, negative 20 over 2 times negative 0.5, which was 20. And x was 20. Now, if you answer it in the context of the problem actually said the x represents hundreds of dollars. So $100 would have been 2,000. But it didn't ask for profit. Don't calculate the profit. Understand what you're being asked for. Okay, the number 11 was, and when it says algebraically find all the real zeros, it means no calculators. Okay, no calculators. It means factor, quadratic formula. Really, that's what I expected. It was one of those. What I got a lot of from that one was people looked in the calculator and found some, or am I looking at the right problem? 11. Yeah, I'm trying to remember if it's that one or maybe it's the previous problem. But anyway, we were really looking for one of those things. Set the f of x equal to 0, solve. And it was a fairly easy factoring problem. You should have done the, right, factor out a 2, because every term there had a 2 in it. So you could have factored that out, and then what's inside parentheses is a very simple one-step factoring, right? X minus 3, x minus 4. I would say the minority who did it by factoring actually did that. Most actually treated it like the 2 times 24 is 48, find the factors of 48 that add up to negative 14, and still got it right in that way. Okay, the next was it just says divide. Do long division. No other directions to it. And the thing you had to notice was it was missing an x to the third term and it was missing an x to the first term. So what do you do when that happens? Fill in with 0 coefficients terms, right there and there. Okay, so if you go through the math, I would say that there were mistakes along the way. The most common mistake is usually, it always starts right here. That first time you've got to subtract, right? That's the 0 minus negative 2, which makes that a positive 2. So that's a fairly common mistake. Then this was a 0, then you brought down a 0. For the most part, a lot of people got that one right. And usually if you didn't get all the credit, it's because you made some minor error in there. Yes? Let's see. let's see. But when you multiply x squared, that should have been x squared times 3 is 3x squared. You had 6.
Oh, okay.
Yeah. Okay, number 13. Number 13 was, it says find the vertical asymptotes, horizontal asymptotes, and the domain. Okay, how do you find the vertical asymptotes? It was part of sketching the graph at the end. It's the zeros of the denominator, okay? But look at the denominator. If you set it equal to 0, it factors rather easily. That's x times x minus 3. So what are the zeros? 0 and 3. So it should have been x equals 0, x equals 3. Without the x equals, it's not a vertical line, okay? What does that make the domain? X does not equal 0, x does not equal 3, okay? Horizontal asymptote. Remember, what does the horizontal asymptote depend on? The degree of the numerator, degree of the denominator. Okay, what is the degree of the numerator here? It's x to the third. It's not x squared because that is 2x squared times x. That's x to the third. So actually, it's got a higher degree in the numerator, which means there is none. That's what it should have been. Now, there's a mistake on there. And, you know, when I make a mistake on something like this, that just means you got more ways to be right. Okay, it's not more ways to be wrong. It's more ways to be right. And some pointed it out. But notice that if you factor this denominator as x times x minus 3, one of those vertical asymptotes, the 0, cancels with a 0 in the numerator, which means it's not going to be a vertical asymptote. It's going to be a hole in the graph. It's not really a vertical asymptote. It's still not in the domain. Okay, x equals 0 is still not in the domain. But if you caught that and didn't give the x equals 0 for a vertical asymptote, that should have been okay, because that's actually correct. Okay. The next one said find the zeros of this function. Same function. Again, how do you find the zeros of a function? The zeros of the numerator. If a fraction equals 0, then it's got to be because the numerator equals 0. So you set the numerator equal to 0, and you get x equals 0 and x equals negative 2. Except for the fact, again, that actually that 0 is dividing out with a factor in the denominators. So it's really not a 0 on the graph. If you said it was, that was fine. If you didn't, that was fine too. Negative 2 was definitely a 0. Okay, so more ways to be right when I make a mistake like that. Okay, the next one was find a slant asymptote. Right, and how do you find a slant asymptote? You divide, right? I mean, the problem said find the slant asymptote for this function. How do you know it has a slant asymptote? Yeah, the numerator has a power which is 1 more than the denominator. That means there's no horizontal asymptote, which we already said in the previous problem, right? But there is a slant asymptote. And how do you find it? Long division. So when we do the long division, right, you should have gotten 2x minus 1 with a remainder, right? But remember, what part of that is actually the slant asymptote? Just the 2x minus 1. And specifically, it's y equals 2x minus 1. This thing is a line. 2x minus 1 is not a line. Y equals 2x minus 1. That's a line. So don't forget to put that part. I think there was a few that thought it was the remainder was the slant asymptote. And there were some mistakes in just calculating the, doing the long division. But a lot of people did get the 2x minus 1. And then the last one was, it was extra credits. It was graph a rational function. And I was very liberal in the way I graded this. Really, there should have been all those things that we did when we graphed these in class. You should have started out with the y-intercept, which was f of 0, and that was 0, right? The y-intercept, right? So meaning plug in 0 for x, and what was left was 0 over negative 1, which was 0. Find the x-intercepts. The x-intercepts are the zeros of the numerator, which is 0. So you had 1 point already, which was 0, 0, right there. Find the vertical asymptotes. The vertical asymptotes are the zeros of the denominator, which, you know, if you solved it like x squared equals 1 and took the square root, you should have had plus or minus 1, not just 1. If you factored it like I did, x plus 1 times x minus 1, then you clearly had both 1 and negative 1, so you sketched those in. And the horizontal asymptote, since they have the same degree in the numerator and denominator, should have been 3, y equals 3. So sketch your line there. And fill in, I did a table of values and put in a few points. You should have had one branch up here above the horizontal asymptote. You had one branch in between the x equals negative 1 and x equals 1. It hit the 1 point we knew on the graph, 0, 0, went back down again. And then another branch up here. That was it. So questions on the test? Yes? For which one? Okay, you're right. I'll fix that. Anybody else? Mason? What you got?
Is this saying this is actually the correct answer?
Yeah.
Okay.
Okay. Let me stop.